Welcome to Rate Laws, Calculating Rate Constants. For this section, you need to make sure you have your calculator, a pencil or pen, and paper. As we go through the lecture, feel free to pause the lecture at certain instances if you need to. Look at the examples, look at the concepts, make sure you understand them. If you don't, write those questions down. Hopefully, by the time we finish this section, that question will be answered. But if it is not, please make sure that you not email your teacher with the question, but post your question in your teacher's office hours discussion board. Posting your question there will not only benefit you, but benefit someone else who either also has that same question or did not think about that question as they were going through this section. I hope we're ready to begin. Let's get started. In calculating rate constants, you can actually use the rate law to calculate your reactants, the process of making your products, and the rate of the overall reaction. Here we have a table, and we have already set up your rate law expression. So since we've already learned how to create this rate law expression, we've learned how to find the order of the reactants, we've learned how to calculate the overall order of the reaction, we're going to start at the rate law expression and work our way from there. So how do we do this? Well, first of all, we can use any one of the three independent experiments to calculate the rate constant. Remember, the rate constant is the lowercase k. So we have to manipulate this equation so that we are going to make everything equal to that lowercase k or that rate constant. So the first thing we do is we choose. In this case, we're going to choose experiment number 2. We see that our concentration A is 1 molar, our concentration B is 2 molar, and our rate is 2.5 e to the negative 2 molar per second. What we're going to do is we're going to substitute this information into our rate law expression. Here is the substituted information in our rate law expression. You have your rate of 2.5 e negative 2 is equal to your lowercase k, which is your rate constant, times the concentration of reaction A, which is 1.0, to the 0 power, because it has an order of 0, times the concentration of reactant B, which is 2.0, to the first power, which is the order of reactant B. Then we set it up to solve for K. Well, to solve for K, you need to remove this information because it is multiplied to K. And if something is multiplied and you need to move it out of the way, you have to do the opposite of the process, which is to divide it. So we're going to divide the concentration of 1 to the 0 power times 2 to the 1 power by both sides. When we do that, we now are setting up our equation for the constant. So clear your calculator. Put in 2.5 e to the negative 2. Now I'm going to pause there. Remember, if you're going to use the times 10 to the negative 2, you must put that in parentheses so your calculator can see that it is one thing. Then we're going to divide that by, open parentheses, 1 caret key 0 times 2 caret key 1, close your parentheses, equals K. So let me write that out. so you can see what I'm doing. 2.5 e to the negative 2 divided by, in parentheses, 1, then I push my caret key, 0, times 2, then I push my caret key, 1, close parentheses, hit the equal sign. Okay? Pause the video. Make sure you can do that application. When you're ready, press play again. Your solution should be 1.25 e to the negative 2. Could you round that? Of course. It could be 1.3 e to the negative 2. It could even be 1 e to the negative 2. But let's try and be as accurate as possible. My recommendation is that you always round it to the nearest 100th. Then when you're doing your problems, look at your answers and see which one fits. If we have rounded it to the nearest 10th, then round it to the nearest 10th. Is this answer the only way that can look? No, because this is in scientific notation. If I took it out of scientific notation, my answer would be 0.0125. That is the same answer. So this is scientific notation. This is not. Another thing I want to point out to you, and I'm going to go back just a hair. Where you see a number to the 0 power, remember we said that any number to the 0 power is equal to 1. So do I need to actually write this in the equation? No. I can just put in 2.5 e to the negative 2 divided by 2, and I will put this in parentheses myself, caret key 1. Will that work without being in parentheses? Probably so. You can try it and see if you get the same answer. But for right now, clear your calculator. Put in 2.5 e negative 2 divided by, open parentheses, 2, caret key, 1, close parentheses, and you should get the same answer that we got before, which is 1.25 e to the negative 2, or your calculator is going to show 0.0125. Pause the video if you need to. Make sure you understand what we did. If you have question, write it down. Press play when you are ready. Here's example number 2. Now remember, we've already calculated the rate law for example 1 and example 2. So we're just using the rate law expression to calculate what our constant is. For example number 2, we are going to use experiment number 1. Now, I want you to do the same thing we did before. I want you to do the substitution, set up the K, and solve for K. Pause the video, and when you're ready to check your answer, press play. So we set up by substituting our information in. Our rate is 1.43 e to the negative 6. That is equal to our rate constant times the concentration of the A reactant, which is 0.250 to the second power, times the concentration of the B reactant, which is 0.250 to the first power. Set up to solve for K. And we have 1.43 e to the negative 6 divided by 0.250 to the second power and 0.250 to the first power. Oh, wait a minute. Did you notice that you could have added these powers because they have the same number to them? So you could put 1.43 e to the negative 6 divided by 0.250 to the third power. You could very easily have done that. Okay, that's equal to k. When we solve the equation, you should have gotten 9.15 e to the negative 5 k, or your calculator, if you have it set up, could be 0.0000915. I don't think your calculator would do that, but if that's the number you got, that is the same number. Remember, this is scientific notation. This is not. The reason we use scientific notation is for very small numbers mostly, or very large numbers. We do use them for numbers that may or may not need to be in scientific notation that can easily be written. But generally, we use them for small numbers. Something like this would be considered a small number. So it'd be easier if we just do it in scientific notation. If your calculator does not know how to put it in scientific notation, that means you don't know how to put it in scientific notation, and you need to learn that process. Otherwise, you can toggle between scientific notation and the regular number as you see fit or as you need to. What I usually recommend, especially with the calculators that we give, is that when you're doing a problem, you complete your problem, get your answer, check the answer choices if they're there, if it's multiple choice. If the answer choices are in scientific notation, then make sure that you change or convert your answer to scientific notation. If the answer choices are not in scientific notation and you have scientific notation, convert it back to the normal number and then do the comparison. Remember that before you round any number, even to the nearest 100th, that you don't round any of the numbers you're using to do the problem until the very last number. That's the only one you consider rounding. Otherwise, every number that you have in the process of getting your answer, you need to leave those. And that's because we're trying to get it as accurate as possible. Okay. So here's your first practice. Remember the F2. Remember the ClO2. We calculated what the rate law expression is. What I want you to do is choose any one of the experiments that you want to. Substitute that information in to the rate law expression and solve for the rate constant. Pause the video so that you can do the application, and then press play when you're ready to check your answers. I use experiment number 1, and my constant is 1.2 e to the negative 2. Now, just in case you got that incorrect, let's set this up, shall we? 1.2, oops, make sure I got this right. Hold on, I've got my eraser. 1.2 e to the negative 2 divided by, in parentheses. Oh, let me go back so I can look at my rate law expression. You think I would know that by heart, wouldn't you? I do not. Not at all. There we go. So, 1.2 e to the negative 3. Could be a little bit neater. There we go. There we go. Okay. Divided by. Now, I know that my F2 has a concentration of 0.250. 0.10, and it is to the first power. ClO2, while it has a concentration of 0.010, but it's to the 0 power. So I'm even going to save myself some time. I'm not even going to do this one because I know that's equal to 1. I might as well just say this times 1, okay? Put it in parentheses if you want to, and push the equal sign. So when I clear my calculator, I would put in 1.2 E negative 3 divided by, in parentheses, 0.10, caret key 1, close the parentheses for safety's sake, and press the equal sign. And that is what is going to get me that final K value, which is 1.2 e to the negative 2. Pause the video, redo that problem, make sure you understand it, write your questions down. And if I've answered any of your questions up to this point, go ahead and mark that question off because you don't need to post it. Practice number 2. This is that H2 and that O2. Choose whichever experiment you want. Pause the video. Solve for K. Come back and check your answer. The answer for this in using experiment number 2 is 5.3 e to the negative 2 is equal to K. Once again, if I set this up using the rate law for my guide, I'm going to put the rate, which is 4.8 e to the negative 3, divided by my concentration of H, which is 0.150 to the 0 power. You can already tell what I'm going to do with that, right? And then my concentration of oxygen, which is 0.300 to the second power. I'm not going to waste my time on this because it's the same as saying 1 times this. Okay? When I clear my calculator, I'll put in 4.8 e to the negative 3 divided by, in parentheses, 0.300, caret key 2, close parentheses. And that is what is going to get me the same answer, or should get you the same answer as 5.3 e to the negative 2 for K. Now, look at this. In this equation, you have your rate law expression here, and I have given you your parameters. I've given you your K value of 4.5 e to the negative 4. I've given you the concentration of A, which is 0.35. I've given you the concentration of C, which is 0.12, and I've given you the rate, which is 6.5 e to the negative 6. Your job is to find B. We set that up the same way you set up to find K. This is what you want to solve for. Remove everything else from it. So go ahead and see if you can do that problem. Pause the video as necessary and press play when you're done to check to see if you got it correct. Okay, so setting up the equation, I do my substitution. My rate is 6.5 e to the negative 6. My K constant is 4.5 e to the negative 4. The concentration of A is 0.35 to the 0 power. The concentration of B is unknown and to the first power. And the concentration of C is 0.12 to the second power. I need to solve, again, for B. So I'm going to do like you do in math. To get everything away from B, we have to divide. This is B set up. Your calculator should have put in 6.5 e to the negative 6 divided by, in parentheses, 4.5 e to the negative 4. Am I going to need this? I'm not going to use that. Times 0.12, caret key 2. I would put the whole thing in parentheses, of course. And that is going to give you your answer of 1 molar. And since b is to the first power, here's your answer. You have solved your question. Look at it carefully. Go back and redo this problem. Press play when you're ready to continue on. Practice number 4. In this one, you're given K of 3e to the 6. You're given B concentration of 0.05. You're given C concentration of 0.21. You're given the rate of 3.8 e to the negative 4. First of all, go ahead and set this up. Do your substitution. Pause the video. Press play when you're ready to continue. When you set this up, here we find that we are solving for A. But I want you to pay particular attention to the fact that A, that's going to disappear. Let me fix that. A is to, there we go, that'll be better. A is to the second power. That means that if you're solving for A, and A is to the second power, you've got to reduce that from A to the second power. That means you're going to have to find the square root of that answer. So take a moment and find your square root key on your calculator. Once you found your square root key, if you have a displaying calculator, you'll be able to see your square root key and then put in the information. But remember, once you press that square root key, you're going to need to use parentheses, maybe heavily. I've got to go through this equation with you and we'll see how heavily we need it. If you don't have a displaying calculator, you need to solve for this first, for A to the squared, and then you need to press your square root key, okay? Take a moment to pause, find your square root key, and do something like the square root of 4 to find out whether you can put in the square root, 4, press equal and get 2, or do you have to put in 4 and then press the square root key? When you're ready, press play, and we will continue. All right, so we've got to solve for A. Well, when we solve for A, we put 3.8 e to the 10 and divide it by, in parentheses, 3 e to the 6 times 0.05 caret key 1 times 0.21 caret key 3. Your answer to this is going to be 2.7 e to the 1, or 27 molar. But that is equal to A squared. I don't want A squared. So you can't stop there. So no matter what you do, if I didn't ask you for that, you don't stop. You don't stop. Because I'm not asking you for A to the square. I'm asking you for just the concentration of A. So then I have to find the square root of 2.7 e to the 1, or the square root of 27. Once I find the square root of 27, then I know my answer. And in this case, your answer is going to be 5.23 e, 5.23 molar, sorry. Now, the neat thing about this slide is it shows you every step of the way what you need to do. So pause the video. Follow every step that this slide gives you. Do the setup. Then solve for A squared. Once you have A squared, find the square root of that, and that should give you 5.23. But please notice that the way this is set up is for what we would call a non-displaying calculator. That's a calculator where you would calculate the problem and then you press the square root key. If you have a displaying calculator, then your square root key would be right here. And then this would all be in parentheses. And that is going to take you directly to this answer. So it all depends on what type of calculator you have. Make sure you are familiar with your calculator and that you get this answer. Press pause, do the problem, write questions if you have them, and then press play when you're ready. Okay? That ends this section of rate laws calculating the rate constant.